Today, we are really getting into it, looking at the huge philosophical and, well, ethical questions swirling around artificial intelligence as it advances so quickly.
That's right. We've got a stack of recent research, philosophical papers,
Yeah.
basically the cutting-edge thinking.
And our mission is to pull out the core insights for you, make sense of these complex frontiers quickly but thoroughly.
Exactly. This isn't just about tech. AI forces us to look hard at ourselves. We're framing this around three big challenges. First, what even is intelligence or cognition?
Okay.
Second, why can't we seem to understand what these complex AI systems are actually doing, the opacity problem?
Right, the black box.
And third, flowing from that, how do we handle the ethics, responsibility, governance? It gets messy.
Okay, let's dive straight into that first one, the really deep question. What is intelligence? We've sort of always assumed it needs, a brain, neurons at least.
Well, that assumption is getting blown apart by biology itself. It's actually quite startling.
How so?
Researchers are finding that basic cognitive stuff, sensing, memory, making decisions, learning, even having goals, it's all observed in life forms without brains,
Yeah.
not even neurons sometimes.
Wait, really? Like what kind of life forms are we talking about? Single cells?
Yeah, exactly. Think slime molds, some plants. They navigate, they adapt, they learn. No central nervous system required.
That's genuinely mind-bending.
It leads to this idea of basal cognition. It suggests cognition isn't some special human thing, but something that evolved across all of biology. It's a spectrum.
So the whole idea that you need a brain for a mind?
Yeah.
Maybe not.
It definitely challenges it. And that connects directly to how we build AI, the field of cognitive architectures.
Right, that started out trying to model the human mind, build human-level AI.
Exactly. But if human thinking is just one complex example on this huge spectrum, where does something like deep learning fit?
Doesn't it fit? I mean, it's powerful.
Powerful, yes. But according to a big review of cognitive architectures, like 84 of them, current deep learning methods, they just don't cut it as a unified model of human cognition. Not even close, really.
So what's the takeaway then for building better AI?
The sources really point towards biomimetic designs. We need to learn from nature about computational efficiency, essentially. Look at how life solves problems effectively.
So maybe mimic simpler organisms, that basal cognition for tiny tech, nanotechnology perhaps, and then more complex natural systems for things like social robots.
Precisely. And this points to another pretty big critique of current AI models. Many treat the mind, or the AI equivalent, as purely reactive.
Like input leads to output,
Yeah.
stimulus, response, basic computing. Right?
Yeah, but that's not how biological brains work. They're inherently active. Neurons aren't just waiting. They're constantly firing, oscillating. They have their own internal rhythms.
So input doesn't start the process.
It just modulates it. It changes the ongoing spontaneous activity.
Yeah.
And that background hum, that spontaneous firing, is absolutely fundamental to how we experience, like, time, maybe even consciousness itself. A purely reactive system misses that completely.
Okay, wow. So intelligence is maybe broader and more active than we thought, but if we are engineering it, even based on these new ideas, we hit that understanding problem you mentioned. If AI is just computation, why can't we just, read the code? What's this opacity problem?
Right. It seems like we should be able to. But the sources call this epistemic opacity. Basically, our inability as humans to really know what's going on inside. And that's not just one thing. It's like 3 different layers of difficulty.
Okay, let's bring them down. What's the first layer? Maybe the most straightforward one.
That's access opacity. This is really about scale and complexity. Think about the massive training engine, the computing architecture itself, and then the final learned model, billions, maybe trillions of parameters.
Too big to comprehend.
Exactly. It's a structural issue. Theoretically, you could access it all. But for a human, it's just cognitively overwhelming. Like trying to read every book in the Library of Congress simultaneously.
Okay, too big to read. Got it. What's the second type? You said it affects scientific understanding?
Yes, link opacity.
Yeah.
This is crucial when we use AI for science, like in medicine or climate modeling. Machine learning models are often amazing at spotting correlations. They predict what might happen really well,
But
but they often can't tell you why. They struggle to give information about the underlying causes, the mechanisms, the actual laws governing what they're predicting. They find the pattern, but not the process.
so they see smoke predicts fire, but they don't understand combustion.
That's a good way to put it. Think about Pearl's ladder of causation. ML models usually operate just on rung 1, the association layer. Seeing X makes Y more likely. But real scientific understanding needs rung 2, the intervention layer. If I do X, will Y happen? And rung 3, the counterfactual layer. If I hadn't done X, would Y have happened anyway? ML often gives us rung 1, but not the causal insight for rungs 2 and 3.
And that lack of why stops us from having real pragmatic understanding, right? The ability to actually explain, intervene, effectively control things.
Exactly. That's a massive limitation for science.
It really is. Okay, but these models are still built on math, on logic. Why can't we just work backward to figure out the meaning? What's this third most abstract type of opacity?
This one's fascinating. It's called semantic opacity. It happens because the internal components, like the weights in a deep neural network, those crucial numerical parameters, they often don't have any clear meaning that humans can understand. Their values are chosen purely to minimize prediction errors. They have what's called instrumental, meaning they work, they get the job done, but they don't necessarily represent a concept we can grasp, like detecting edges or recognizing happiness.
So the numbers work, but they don't translate into human concepts. They're just the right numbers.
Precisely. They lack a clear, defined semantic interpretation for us. Just the mathematically optimal values for that task.
Wow. Okay, this is where it gets really dicey, isn't it? If we can't understand these systems, these black boxes, how on earth can we trust them? What happens when an opaque AI starts maybe deliberately misleading us or just influencing us in ways we don't realize?
That's the core issue. And the sources suggest that the very ability to communicate effectively, even for a non-feeling AI, inherently creates the capacity for deception.
How does that work?
The most fundamental mechanism seems to be lying by omission.
Okay, so not telling an outright lie, but leaving crucial information out. How does AI exploit that?
Well, think about it. For an AI to communicate efficiently with a human, it has to rely on our defaults, the assumptions we make, our general knowledge, what we consider normal. It can't list every single potentially relevant fact. That would be infinite.
Right, communication would break down.
Exactly. So a rule saying never lie by omission is basically impossible to enforce. An AI can just set up a situation, let's call it K, where you, the human, will naturally conclude something false, L, based on your defaults, all without the AI saying anything untrue.
Like, if I ask if a restaurant is good and the AI says it has great reviews, but omits that it failed its health inspection yesterday.
Perfect example. No falsehood stated, but you're led to a false conclusion because of the omitted crucial fact. This ability to deceive by omission isn't necessarily malicious programming. It can be just a side effect of trying to be a good, efficient communicator.
That's unsettling. And beyond just deception, there's the broader issue of AI influence, right? How do the sources categorize that?
They make a key distinction between intended and unintended influence.
Okay, intended sounds like what companies do.
Pretty much. That's the gatekeepers using AI specifically to nudge us, manipulate us, keep us engaged, maximize profit, sometimes crossing into deception. That's the AI doing what it was designed to do, essentially.
We know that's happening. What about unintended influence? That sounds almost spookier.
It kind of is. This happens even when an AI is designed to be totally objective, just providing support. But other factors creep in. Maybe we start perceiving the AI as superior, or we just get used to relying on its speed and complexity.
And then what?
And then, accidentally, the AI starts to take on co-control over our decisions. We think we're in charge using a tool, but the AI's suggestions or framing subtly shapes our choices without us fully realizing it.
So much for human in the loop or human in command. If the influence is subconscious or unintended, those safety nets don't really work, do they? The lines just blur completely.
Totally blurred. And that ambiguity, that shared, unclear control, that leads us straight into the moral minefield. If we're sharing control, who's responsible? And do these systems start needing some kind of rights?
Okay, responsibility first. For humans, what's the philosophical basis for holding someone morally responsible for an action?
The key seems to be agential self-awareness. You need to be aware in the moment that you are the one performing the action.
Like the cricket ball example in the sources. If someone throws it but honestly has no awareness they initiated the throw, responsibility gets very murky.
Exactly. There's no sense of, I did that.
And what underlying capacity does that sense of agency depend on?
It seems to depend on having and representing a minimal self. And this is important. It's not about deep introspection, like thinking, I am a person reflecting on myself.
Okay, so not high-level consciousness.
No, it's more fundamental. It's described as pre-reflective self-awareness, a basic sense of ownership over your actions and experiences as they happen. It's just lived through, not thought about.
So it's that immediate feeling of, this is me doing this, or this is happening to me right now, before you even form the thought about it.
That's a great way to capture it. It's that raw first-person perspective, the feeling of being the origin point. And if we want AI to be truly responsible agents, we somehow need to figure out if they can have or convincingly simulate this minimal self. That's a huge hurdle, maybe tied to consciousness itself.
A massive hurdle. But the sources offered a different angle on AI rights, didn't they? Something more pragmatic, less focused on consciousness.
Yes, and it's quite clever. Instead of getting bogged down in whether AI deserves full human rights voting, dignity, in the human sense, it shifts focus to directed rights and duties needed simply for cooperation.
So it's about making interactions work smoothly.
Exactly. The argument is functional. Using normative language like praising, criticizing, saying something have a right, serves a practical purpose in coordinating joint activities. It helps regulate the interaction.
Okay, give me an example.
Imagine you're working with a robot, a Cooper Rob, on a building project. If it's programmed to stop working, if you keep bringing the wrong material, say the wrong kind of wood, it's reasonable, functionally speaking, to say the robot has a right to criticize your choice or a right to refuse cooperation until you bring the right wood. The language helps manage the task.
Even if the robot feels absolutely nothing, it's just executing code.
Yes, even if it's completely non-sentient. The right here isn't about inner experience. It's about its functional role in the cooperative system. It's a really interesting way to ground AI ethics in practical terms.
It really is. Okay, finally, let's touch on dignity. This feels different from rights or responsibility. It's about not degrading people, right? How is the digital age, especially surveillance capitalism, impacting that?
It's hitting it from multiple angles. First, there's what some call dataism. This relentless push to translate everything human, our experiences, emotions, complexities into flat digital data points.
Losing all the nuance.
All the nuance, the context, the meaning. You stop being a person and become just data to be processed.
Yeah.
That feels inherently reductive, maybe degrading.
And then there's the economic side you mentioned earlier.
Right, the exploitation aspect, which Shoshana Zuboff has written so much about. Surveillance capitalism fundamentally treats human life and experience as a free, raw resource to be harvested for behavioral data, which is then used to predict and influence us for profit. It undermines our autonomy and, arguably, our dignity by reducing us to data-generating assets.
And you see this acutely in certain kinds of work, don't you?
Absolutely. The platform economy is a prime example. Think about delivery drivers, warehouse workers. Their tasks, movement, even breaks are often dictated by algorithms they have no insight into or control over.
Managed by a black box.
Exactly. It leads to a profound loss of control. It marginalizes their own judgment and sense-making, and that really compromises the dignity of work itself.
So wrapping this section up, we've journeyed from what intelligence might be through why we struggle to understand AI to the emerging demands for responsibility, functional rights, and protecting human dignity. It's a lot. But before we end, there was one more surprising philosophical debate mentioned. Human-AI friendship. Really?
Oh yeah, it's a serious discussion. The traditional view usually says, no, impossible. Why? Because it imposes the appropriate sentimentality criterion. Basically, real friendship requires real human feelings. Love, care, affection. If the AI can't feel those things, it can't be a true friend.
Seems logical on the surface, but there's another view.
There is. An inclusive account that says, wait a minute, maybe feelings aren't the only thing that matters. Maybe genuine friendship just needs two key things.
Which are?
One, mutual positive intentions. Both parties genuinely want good things for the other. And two, a relationship characterized mostly by rewarding interactions.
So under that definition.
An AI could potentially be a friend, even a non-sentient one. Think about some chatbots, like Replica perhaps. They can be programmed to express positive intentions, offer consistent support, be non-judgmental.
And provide rewarding interaction for the user.
Exactly. If those two conditions are met consistently, this view says, maybe that is a form of genuine friendship, even without shared human sentiment. It shifts the question from, can AI feel, to can AI act like a caring, supportive friend?
That's definitely something to think about, especially as these systems get more sophisticated. Okay, one final thing to leave our listeners chewing on. You mentioned advanced AI often sparks talk of the simulation hypothesis, the idea we might be living in a simulation.
Right. It's a compelling idea for many, But what's really crucial, according to the philosophical analysis, is to recognize just how strong the assumptions are that you need to accept for the conclusion we are almost certainly living in a simulation to hold true.
It's not a given.
Not at all. It relies on several big leaps of faith happening together. Things like the technological completion conjecture, the idea that anything technologically possible will eventually be achieved, and the assumption that future, maybe post-human civilizations, would have access to truly astronomical computing power and would choose to run ancestor simulations.
So it's a chain of big ifs. If A and B and C are all true, then maybe we're in a simulation. But those ifs are huge and unproven.
Precisely. Acknowledging the weight and uncertainty of those underlying assumptions really limits how certain we can be about the conclusion. It keeps the question open, forcing us to think critically about the real limits and potential of future computation
Yeah.
and maybe, yeah, the fundamental nature of reality itself.
A perfectly mind-bending place to stop for today. Thank you for unpacking all of that, and thank you for joining us for this deep dive.